Okay, so we're going to do area of regular polygons. I'm going to bring some regular polygons up that you already know the area to. We're going to try to develop a formula. So hold off on, look, if you could put your books, close them up. Let's just go through this together because there are things to look for that go all the way back to even the special triangles from last semester. So you have to draw on things you maybe might have forgotten. So that's something that the book, I would say mostly in the homework tonight, it's simple, but by the time we test, there's more challenging math, like using special triangles. So hopefully I'll get to that today. So the goal today is to be able to find area of any kind of polygons, obviously triangles, squares, pentagons, hexagons, and so on and so forth. Okay, so, you know what I should have done? Let me look at something. So, every single regular shape, I don't know if you heard what Josh said, can be divided into congruent triangles. If you think about this, if you think about area that way, then you can figure out all of these with one general formula. So if this is a triangle, it doesn't have to be equilateral, but in this case, this triangle, if we look at this equilateral triangle, hopefully from the last couple days you've been able to review that your area is base times height divided by 2. And the other ways to think of that is half the base times the height, or half the height times the base. We talked about all that. Yes, Connor.
Was that the thing that was in last month's homework, where it was like S equals S minus A times B minus A times C?
In one of the end problems. Yeah, where they kind of preview the next section.
For triangles, or is that for?
It's this. It comes into all of this. So your book always previews what's coming next, and I think the answer to your question is yes. I can't remember the specific problem, but if we look at all of these shapes here, these 3 for example, you could think of them because they're regular, they all have a center point, center of gravity. And if you say take that a little bit further, and maybe just go a little further here, like in a hexagon, you could break this into 6 equal triangles, and then in a pentagon, you could break them into 5 congruent triangles. And what do you need? Just use one. And then in a square, you could break it into 4 equal triangles. Technically, in a triangle, you could do the same thing. And break it into 3 equal triangles, but we don't want to make a triangle harder than it is. Yeah. We know how to find the area of a triangle, but actually the rule would apply. We do. We know the square, but the rule would apply. And there's a reason that I'm actually doing that, because sometimes these 2 situations, you have always been given the height and the base, but if you think way back into first semester, you should be able to figure out the area of an equilateral triangle with only the height. You don't need the base. So we'll talk about that in a minute. Okay, but let's just take a look at, say, the hexagon. For some reason, a lot of times that's the one that's easiest for people to look at. You know, you often see a hexagon divided into 6 congruent triangles. Okay, so if I pull this triangle out here, in the original hexagon, so in this original problem here, in your book, like what Connor was talking about in the homework last night, they used an S for side lane. They're going to use that general S.
Wait, I thought S was semi-perimeter.
Oh, so you were talking about something different then. Oh,
Well, it was like.
so there's different things. I thought you were talking about different problems,
I think it was just for triangles was what it was. Yeah.
which is Heron's formula.
Yeah.
That's a
Yeah.
really
Whatever
handy
root,
formula.
like S and then
Yeah.
S minus A.
Right. So that's not related to this,
Okay.
but that's a great formula to have memorized. It's really handy. So in your books, you're going to see your regular polygons are going to have an S for all the sides. And in order to figure out the area of this red triangle, we would need to know this height. Now, normally we call that the height. But in a polygon, the segment that's drawn from the center to the side at a right angle to the midpoint of any one of the sides, that's actually called an apothem. So this is called the apothem. So they denote it, not apothem, but apothem. Yeah, that was right. So they denote that with the letter A. So you have an A here, and you have an S here. Now, to be honest with you, when I do regular polygons, I actually sometimes use a formula, and sometimes I just figure out the area of one triangle and multiply by how many there are. It just depends on the situation, which is quicker, what information I have. But that's a new vocab word. And with that, if you look at this triangle here, the area of this triangle is going to just be the base times the height divided by 2. Right? And there are how many triangles here? 6, right? So the area of the hexagon would just be 6 of those, right? 6 times the base times the height divided by 2. So it's 3 AS in this case, right? So in the Pentagon, they still will denote this height of one triangle as the apothem. So for the area of this pentagon, it's just the area of the base times the height divided by 2, but there's 5 of them, right?
Wouldn't it just be times the number of sides?
Exactly, times the number of sides. Then they use that. What letter do they use for that? They usually use this as they call that N, right? And so your algebra books are really big on formulas. Well, you can come up with a formula, and for some of you that's really important because you think in formulas. So even going to the square, which we would probably not do this, it would still work. You would have the area of the base times the height divided by 2 times 4. Okay? And so in all 3 of these formulas, if you look at them, so looking at a pattern, we had 4 SA over 2, and then 5, that's a 5, SA over 2, and the other one was 6, SA over 2. So this is your number of sides. So your formula is going to have what in it? An N, right?
So N times parentheses
SA over 2.
Yeah, so this is called the apothem divided, and it's divided in half and it times the number of sides. So all 3 of these pieces are in each one. You see that? So there's 2 formulas that you would get for regular polygon area. So one is the area of a regular polygon is, you'll hear 1/2 the apothem times the perimeter. Why is that the same?
Oh, because it's like this is sides.
Where's the perimeter in this? What makes the perimeter?
All
The sides times n, right? So this is a very standard formula that you're going to see in future books, in your student handbook probably. But the other way you would see it is 1/2 the apothem times the number of sides. So times the number of sides times the length of the sides. The other standard formula. Area. So those are your formulas. You don't need to use them all the time if they're not helpful. Like if it's helpful for you just to get the area of one triangle and multiply by how many they are, if that's the way you think, then do it that way. If you're a formula person, use the formula. But when it goes to trying to solve bigger problems like your book always does, going backwards, then you have to know both. So here's some sample problems. The harder of the problems is when you're not given all the pieces. So hexagons are great examples of where you have all the knowledge, but you're not given all the pieces. And even though your book doesn't do this all the time, I'm definitely going to do this because this is more of an advanced level class. You should now be able to find the area, even if I just tell you that the perimeter is, say, 36 inches. Okay? That's all I'm giving you, and you should be able to find the area now. You have to draw upon your old skills. So what do you need? We need some stuff in these formulas, right?
You need interior angle, exterior angle. Oh. No, you don't.
So think triangles. It's okay that you might not get it right away, right? I mean, I haven't given you any help.
You have to, each
But-
side is 6.
Well, I'm putting a triangle in. I just went diagonal so the triangle went through the center. It was just easier for me to get the center that way.
Wait, are these
Up.
triangles,
So if this is only for regular polygons. So there are always isosceles in the shapes, but in the hexagon, they're equilateral.
oh,
Right, so the first thing is that you need to remember that it's a hexagon. So a hexagon has some special properties. They're equilateral, and that's going to help us. So we've got one triangle here, so we could use a formula, or we could just focus on one triangle. It's going to vary from person to person, what your preference is. But let's just imagine this for a minute. What does the 36 give us? What do we know? We know the side is 6. Okay? But what does the equilateral triangle give us?
all 3 sides are 6.
So this is 6, right? This is symmetrical. This is 3.
Oh, so we have to find using the Pythagorean.
Pythagorean theorem. But it's something you could do. It's something you could do. So instead of calling that H now, we're going to think of that in this picture as what is, well, that's the apothem, right? So get used to that becoming the apothem when you read the book. So somebody already figured it out just while I was erasing. What's the height? It's 6 squared by the Pythagorean theorem is equal to 3 squared
Oh, it's opposite.
plus a squared.
Oh,
Okay, back.
So this is 36.
45.
45, so it's square root of
Oh,
45.
wow. That's a square.
Yeah, I think you had that right earlier on, Connor.
Oh,
27.
So when you square root that, simplify, what is it?
5, 45, something.
Okay, how about with exact form? Remember last year 9 times 3? Your factor pairs are 3 times 3. That comes out. So this is 3 square roots of 3.
Whoa, I don't remember that.
Oh my
You don't remember that?
So
No.
I remember that.
I remember it.
Should I practice a few?
Yeah.
Can I come back to it for a minute though? We'll come back and practice.
Yeah.
Just believe me for a minute.
Okay.
Okay, so we can move on, and then I'll come back to that. So this is kind of the higher level thinking problem. Is you have to be able to use formulas, but also be prepared for me to step it up and not give you every little piece if you really don't need it. Tonight the book's going to give you the Apothem and the perimeter.
Students, please excuse the interruption at this time. Ladies who are traveling to El Dorado and Aspen Creek, you are now dismissed. Your bus will be here in about 13 minutes.
So the book's going to give you like more elementary practice problems. They're going to say the apothem's this, the perimeter's this, find the area. The apothem's this, the side's this, find the area. It's good. It's not very advanced. You guys have had a lot more background, so you should also be able to go back and think a little bit more. You should be able to use all these properties that we've talked about. Sometimes you should be able to find the apothem by yourself in a hexagon, for example. Okay? So with that, can you find the area of the red triangle?
Yes.
Yeah, so you could choose to do one triangle and times it by 6, or you can now say that you know this is 3 root 3, this being the apothem, and use the formula. Your choice. So if we use the formula, the area is 1/2 the apothem, which is 3 root 3, times the perimeter, which is 36. And then, let me go back to single page.
Wow, that's giant.
Then let's keep practicing multiplying skills, right? Don't multiply all that out. That's 18, right? Keep practicing those.
Wow.
Because your tendency is to multiply and divide, right? Try not to. Try not to. So then 3 times 18 is
54.
Yes. So 54 square roots of 3. And then unit-wise, if I said the perimeter was in inches, the area is in inches squared.
Yeah.
Okay, so one method is using the 1/2 AP. Do you see how I did that?
Yeah.
Here's the 1/2, here's the A right here, and here's the P. The other method is get the area of one triangle, which is half the base times the height. What's the area of that triangle? The red triangle.
3
Half the base is 3
Yeah.
times the height.
9.
9 root 3, right? And how many triangles are there?
Oh, what?
7.
I forgot what we were doing.
6, right? So each triangle is a 9 root 3. Do you see that?
Yeah.
So there's 6 triangles. 6 times 9 is 54.
Whoa. That's weird.
To the third. 54 square
No.
root.
Yeah, I just said 6 times 9 though. Just showing you could go either way. Can you raise your hand if that makes sense, the goal today?
Yeah.
Okay, I know there might be some questions. Connor, you guys have to go.
How can you figure out? They gave you a perimeter and a
So, Apothem.
apothem.
So,
How would you figure out if it was an end
hold on,
on?
there's a lot of, let's just talk. So that's important. When you see regular n-gon, that just means it's a regular polygon. That means it has, yeah, it's, right, and you have to figure out how many sides, right?
Right.
What do they tell you?
The apothem.
So they give you A, and they give you P, right?
Area. But I don't understand how you would have to divide the perimeter by an X amount of things.
Well, but the formula is 1/2 the apothem times the perimeter. So it doesn't matter, in this case, you don't need to know the number of sides, do you? Because they gave you the perimeter.
Wait,
A equals half base.
Do you see that? Sometimes so that's why I said you're gonna use whatever formula helps you the most. This was one of the formulas.
And the other one was just the half.
So the other one was half the apothem times the number of sides times the length of a side. Well, if they give you the perimeter, you don't need n because that is the perimeter. Do you get that?
I get it.
So and sometimes it's overkill. If you can just figure out the area of the triangle or whatever and just multiply by 6, maybe that's what comes quickest. Be flexible. Yeah.
So when you got.
Did you guys get this question? Because that's important. That's a question that everybody comes back with.
Yeah, I got it.
Stephen, why don't you go sit so you can't make little googly eyes at Josh? And vice versa. Which is what's going on. Okay.
We got the answer, which was 54 times the square root
Going back to that.
of 3.
Sorry, there was like the basketball dismissal. I switched away from that.
Yeah.
So
So could you just leave it at that? And if it was something that you could square
you
root-
would. You could just leave it at that.
Okay, but
Now, sometimes the book has you, so the general rule of thumb is if it's an application problem like last night, a real world situation, you usually go to decimals and do some kind of rounding. Because it makes sense. I mean, if it's an application problem and it involves measuring and money, you know, you really want to get a number that we can work with. If it's what we call like a pure, like just a math problem without an application, no context, usually go exact. And books are inconsistent, and so are people. So if you did square roots and I did decimals, we would just compare our answers. But I'm going to tell you right now, you have to be able to do this kind of example, where if I ever give you a hexagon, you always should realize there's equilateral triangles in there. And with one measurement, you can find the area. You don't need everything. If I gave you, can I do another example?
Yeah.
Of that? If I gave you an equilateral triangle, you have always needed the base and the height, but you don't really if it's an equilateral triangle, right? If I say, you know, this has a base of, say, 12, if this is 12, and you know it's equilateral, you should be able to find the area. Okay? And then we could, so what do we need?
can we go into
The square root thing?
yeah.
It's gonna come up here. What do we need to find the area? Yeah, Luke. Yeah. Well, either. Can you,
Because you know that it's all equilateral, so you know that each half of the base will be 6.
right, you need to think like symmetry.
6 and 12, and you can do the Pythagorean theorem, knowing that you have the hypotenuse and
Exactly, you use Pythagorean theorem.
that.
So we'll call it h squared, right? We would need the height. 144, 36. You're subtracting them. Eight, right? Okay, and that brings us to, can we review square roots? Okay, so I would need to take the square root of 108, and I want you to remember your work from last year. So remember 1 plus 8 is adds up to 9, so 9 goes into this. The other thing is I want you guys to practice some of these little tricks I've been showing you. 9 goes into 10 how many times? Once. What's the remainder? 1. Put it there. 9 goes into 18 how many times? 12. I know, but I've done it a few times this year, and each time I do it, another person goes, oh, you want to start doing that, right?
Very good.
We'll just keep practicing, okay? So now we're looking for factor pairs. And this is 3 and 4, and that's 2 and 2. Somewhere last year, you found factor pairs. Anytime you can get something to pair up, you multiply those pairs. What's 3 times 2? 6. So this, I'm going to write that over here. The square root of 108 is the same as 6 times the square root of whatever is left over, or the product of whatever is left over. Is that coming back a little bit?
Oh, yeah, the cross out thing where we had to.
Now, I'm going to be honest with you, it doesn't come up a lot tonight, but it comes up in this chapter. And if I can introduce it to you a little bit each day, then when you have to use it more, it's not going to be overwhelming.
I remember, because Mr. Few like laid the fact that there's on top of each other, and I
Yes.
that's the match.
Well, that might have been Grace's common factor, at least common multiple.
Maybe it's good.
But it's all related in square root stuff. So do we get that the height is 6 root 3?
Yeah.
And so now we can figure out the area of this triangle is equal to half the base times the height, or you could do base times height divided by 2.
Wait, but why is it root 3? I don't get that.
Yeah, I don't get why it's root 3.
I get that it's the one left over, but why does it have to be square root?
Because I can answer that. I had to think about how I wanted to answer that. Let me go. So what is really going on is 108 is the same as the square root of 3 times 3 times 2 times 2 times 3. Okay? And because they're products, you can write them as the square root of 3 times 3 times the square root of 2 times 2
Oh.
times the square root of 3.
Oh.
And so this is 9, right?
Which is
3. And this is 4. So that's 6. But this is just plain old square root of 3.
Oh, that makes so much more sense.
Okay? It's very common to do that successfully for a long time and never really know why.
Yeah.
And it's also common to understand why and forget. You know, but you just keep asking and then it'll become, you know, you'll forget less. Okay, so do we get the area? Here is half the base times the height, so it's 36 square roots of 3. And if this were in inches, this would be squared inches. You guys put the book away. Close the book and listen. Close it. All of you. Yeah, well. You guys get that? Because the harder problems on the test, you know, I always make harder problems, right? These are the kinds of things. This will help you next year in your Algebra 2 class. It's helped you in your pre-class. It's going to be pre-calc. It'll be on your standardized test. This is like kind of the big thinking.
Wait, what did you just do to make it 36 times the square root?
I did half the base times the height. The reason I did that is the formula, the formula for an equilateral triangle, that it's also a regular shape. So couldn't you use 1/2 the apothem times the perimeter if it's a regular shape? It has an apothem, right? You should be able to figure out the apothem yourself. I could give you a question where you have to figure out the apothem. Because it's an equilateral triangle, you should be able to do that. Luke.
Like, when you were doing this, like, multiplying square roots to find, like, I think it was the 6 and the 3.
Yeah.
Like, the square root of 9, and then you have the square root of 4.
Oh,
And
wait.
then you had 6. I don't understand how you went from that to that.
I hear what you're saying. I'm trying to, I don't know where we did it.
What's the square root of 9?
Yeah, it was the square root of 9.
Which is 3.
And then,
But the square root of 4
but then,
is 2. 3 times 2 is 6.
oh, I was thinking, never mind.
Are you there?
I was just thinking like the square root of 3 or something that didn't work.
That's okay. Connor.
Okay, so to do that,
Yeah, how do you do that?
okay, I have a great idea, but I'm gonna lose it. Okay.
Put the worksheets away. Put them away. Jacob. Put them away. Listen, put that away.
So you do.
Away.
So
Thank you.
you do that right there, and then, oh, hold on, I'm losing it. Okay, so you do that right there, and then you divide the area by 3, so it makes 3
Let me
congruent
change this a
triangles.
little bit. Okay, go ahead. I'll listen to you first. I should have finished listening,
So
and
you
then,
take the area and divide by 3 to get, because this makes 3 congruent triangles, and then you can figure out, you can plug it in because you know the area of one triangle, so you do the
do
area.
you see the 3 congruent triangles? So, can I stop for a minute? Stop you there? So the key is 3 congruent triangles, so I should be able to give you only the apothem. I should be able to give you only the apothem. And you should be able to find the area. If it's an equilateral triangle, because we know, I can tell you that the apothem was 2 root 3. Does anybody know why I can tell you that? Remember this property? This is the centroid. This is the ratio. This whole thing was 6 root 3.
So it's half.
And it's broken into a 2-to-1 ratio. You remember from constructions?
Not really. Yeah, but 2's not half of 6.
So all you have to do is.
No, but this whole thing is 6.
Oh, I remember this part, yeah.
So
you need to take the height.
If you were given the apothem, or go reverse, if you were given the apothem, this is only true for an equilateral triangle, then you could find the height of the triangle, because that would be 4 root 3 from here to here. Remember that?
Oh, because it's,
So the height of this triangle is 6 root 3.
wait, I thought that was median
So you
stuff.
just multiply by 3?
So when we learn triangles, equilateral triangles, if this was 4, this was 2. It's always in a 2-to-1 ratio.
I thought that was median stuff.
These are medians because it's equilateral. Medians and altitudes are the same.
Oh,
Oh, that makes so much sense.
okay.
Okay?
So it was what I was doing, but easier.
Yeah, so even easier. If you're given the apothem, you can actually find the perimeter. You would have to do some work. Which I'm telling you, this is probably a test question in your future, something like this. It's not, and we can do it, but I think we probably should look at some basic problems too. But the goal for you today is to see how the book makes this really easy, but I want you to project to where it's going, to more difficult, even though it's not out of your skill set. You have all the information to do this kind of stuff.
Wait, how do you know it's 2 root 3 then?
I made it up. I said, what if A is 2 root 3?
Oh, okay.
I knew because I looked at 6 root 3 and I divided it into 3 parts. But I'm saying if you have just this page, right, if you just have this, eventually your goal should be, if I give you 2 root 3, you should be able to tell me the area. Do you know how to do it?
Yeah.
How would you do it, Alexis?
So you add 2 root 3 to 4 root 3, and then you get 6 root 3, and then you times that.
How would you get you still need the,
Wait, do you have the base?
you know. How are you going to get the missing pieces? You guys can do this.
Oh, is it,
Call it B. Let's call it X, because it's not B, it's half of it. How can you get that if you know this is 6 root 3?
You just do.
What's this? Let me ask you this. What is it from here to here? But you know this is X. What's this?
it's double X.
It is.
Oh, no.
So can't we say 2X squared is equal to,
Wait, why is this?
because I'm going to do a right triangle here.
Wait, what?
Oh,
Two
because
X
you just
squared,
did.
X squared.
2x squared.
Wait, why is this close?
Because I'm going to do a Pythagorean theorem here. My goal is to go backwards.
2x squared equals x squared plus,
Square root of 3
6.
squared.
6 square root 3.
Oh, I get it, okay.
And so when we do that, this is x squared, this is 4x squared, right? And this is, does anybody know how to remember how to do this? You have to do both.
Oh, yeah. 36.
36 times
9.
3. Careful, yeah.
Oh.
So I have to get my x's together, like terms. 3x squared is equal to 36 times 3.
And then
3x
divide
squared
by
divided by 3.
Did you notice how I did multiply this out?
Yeah.
Don't multiply out, because why?
And then x squared is
Cancel.
X
and then
squared.
x equals 6.
It equals 36. And then x equals 6.
So if x equals 6, that's half the base, right?
Uh-huh.
What's half the base
We already knew that.
times the height?
I think we knew that from the other picture, but that makes sense how to do it.
Height is,
Yeah, we do that.
base.
It's size.
Oh, it's 36, 3 squared.
Yeah, did that not work out? Did I have a,
Well, the other page will tell you if it works out.
I know, I feel like that's not the same value, it should be. Oh, it is. I just remembered it wrong. I didn't remember the number. It did work out.
Wait, if it's square inches,
So it is square inches because it's area?
but it wouldn't like do anything to the square root.
No. Okay. That's a huge problem, but that is your goal.
Will that be on the test?
That is something, yes, quizzes and tests in your future. That's a big problem. You know, but the reason I picked this problem is it does everything you need with regular polygons. Now, your homework, this only works for regular hexagons and equilateral triangles, and the square thing we'll get to later, okay? I mean, other than that, you would have to be given an apothem and a perimeter, or you would have to know trig to do other ones, which we get to later this year. So when you look in the book, they make it way easy. I'm just saying don't get too comfortable because you're capable of doing this, and that's my job this year is to make sure you're doing advanced stuff. So the book does some of this, but maybe not enough of this. They do a great job, just not enough of this. Luke.
So we won't have to find the area of a non-regular polygon?
This is all about finding the area of a regular polygon. Yesterday, doing the surrounding and all of that stuff, you use other techniques for non-regular. Good question. And like I said, you know, I wanted to do this first because I wanted to make sure if people are sick for a long time, they at least get some notes. I'm going to stop that, but we'll do more questions.